Hi, and welcome back to the NVIDIA Industrial Engineering live stream. Today, we're going to be talking about real-time digital twins. If this is the first time of watching this, welcome. We've actually had two episodes before. We did a bit of a recap on what is NVIDIA doing in this space. And last week, we talked about AI physics, building AI surrogate models that can do this real-time prediction. So we decided today, building on that theme, we're going to talk about how you can integrate some of those previous technologies into a digital twin. We're going to be talking about Omniverse APIs. We're going to be talking about kit-CAE and how you can do it. And I thought I'll bring along two of my friends who know a lot more about this than I do, Abby and Ukash, who actually have built this stuff themselves, working with partners and customers. And I thought they would be the best people to talk about it. So if we can bring them on screen, maybe they can introduce themselves, and then we can start to get in. This is going to be like a deep dive session, so this code will be shown. Be warned, this isn't just slides. Yeah, maybe Abby, do you want to quickly introduce yourself for people?
Sure. Hi, everyone. My name's Abigail. I'm a technical marketing engineer. I've been doing my whole career in CFD and computational stuff, and I'm excited to be here to talk about this.
Cool.
Hey everyone, thanks for the welcome, Neil. I'm Utkarsh, and I'm a dev tech, a scientific visualization dev tech here at NVIDIA, and my focus is primarily scientific data analysis and visualization.
And Abby has two very cute dogs, which I really hope will come up in the background, because last time we were preparing this, they were like fighting in the background. And so I kind of hope that actually comes up. Okay, so we don't have that much time. We're going to try and keep these condensed. So I think maybe a good starting point is, what actually are we talking about when we talk about real-time digital twins? Maybe, Abby, I think you've got a couple of slides and a nice video to illustrate this.
Yeah, sure. So we can go ahead and take a look at a slide. I know it's not death by PowerPoint. It's just one slide to get started. So if we can show the architectural diagram. Yeah. So what we're doing is we are putting together blueprints or how to work with some of the technologies that we have at NVIDIA. And I think Neil talked about the real-time wind tunnel last time or in the other episodes. But this is a very basic architecture of how it's created. There's a few pillars of this blueprint. One is PhysicsNeMo, which I think was covered last time. And another one is kit-CAE and how we visualize large data that's often found in CFD simulations and CAE simulations, how we visualize that in real time and in like beautiful environments that are accurate for like how they're actually tested. So that I think that's what we're going to go over today is kit-CAE and how that integrates and enables these blueprints. So we've done a few now, like you said, Neil. We did a car, and then most recently we did an airplane. So if we can go to that to show the video of this blueprint for this airplane. And this was really fun to work on. We all worked on it as a team together, and we showed it off at GTC DC and also at Supercomputing. So what we did here is we took an airplane and we changed, or we allowed the users to modify the flaps and the slats configuration as well as the angle of attack in real time and get results in real time and visualize it in real time. And this is all part of the blueprint that we put together.
Yeah, and this was something that I guess was building on, a year ago. I think we showed like the road car, which is what I showed in the past few episodes. And then somebody was saying, but how could this be done to other things? And so, we showed this to show how you can do it for an aircraft. And we talked in the last episode, I guess, more on the surrogate modeling. How do we train a model using prior simulation data to be able to give this real time? But one of the questions that I certainly get a lot is, well, how could I do this? I'm a developer, I work at an ISV or a startup or a developer another code, and I want to have this sort of capability to visualize a wind turbine, a bike, a data center, a plane. And so I guess today is about getting into the code of the magic behind this, taking back the curtain, I suppose. And yeah, it was fun, wasn't it? It was a bit stressful, but it was
fun
to
yeah, it It was great. And it's, it's really impressive. I think sometimes people see this and they just see, oh, wow, that's beautiful. But what's really impressive, I think, is the accuracy behind it, the technologies that we're hooking together. And one of the ways we do that is with kit-CAE. And kit-CAE is basically a sample of extensions and APIs just brought together to work with large data sets efficiently. So, I mean, as you can imagine, in simulations like this, it could be very, very heavy. And here we're, real-time inferencing. So it's pretty impressive to be able to work with these data and like visualize it in real time.
Can I just interrupt for 1 second? I just pressed the wrong button, so somebody else's comment came up. This is the comment I meant to show. It said, it is, I think they mean, is it like a pre-solved, or is it from PhysicsNeMo? This is actually the real-time inference from the AI model. So this is not a movie. This is not a trick. This is actually the real time. And if you look really closely, there's a black banner at the top saying waiting for inference, and then inference happening, and that's the real time. So sorry to interrupt. Just wanted to answer that question.
No, that's an important thing to show. So yeah, I think today we'll just get into a little bit of how kit-CAE enables working with this data. There's like a few big pillars that come together for kit-CAE. Like I said, it's a sample for developers to see how they could work with their large CAE data. But it involves USD schemas, some algorithms, flow, index, and warp, and also, just data delegates. And I think, Utkarsh, you're going to get into that a little bit.
Yeah. Before we do that, though, can we go back to the movie for 1 sec? I just want to highlight what kit-CAE brings into that equation there. So if you look at the video.
Yeah.
Come on, Zach. Show the video.
Bad network connection, I guess. Anyways, everyone saw the video. So in the video, you saw some graphical elements on the side, right? The toolbars and the buttons. All of that is the web client, right? That's a web client that's written in React. But the rendering, all the thing that's happening behind it, that's the airplane model, the visualization, the flow, all of that is what is coming from kit-CAE. So yeah,
right.
So all that rendering stuff is coming from kit-CAE. What kit-CAE is, it's a Omniverse-based sample application. So the keyword here is sample, right? It is not a product. It's not a thing that you can buy off the shelf or any such thing. It's an example of how you can build this on your own. And it is based on what's called Kit SDK. I'm sorry, I'm just dropping tons of names here, but that's the game, right? So the Kit SDK, as the name suggests, is another SDK, right? It's a software development kit. So it gives you a rendering engine. It gives you a bunch of different extensions that you can put together, bring together in your application, or write your own. So kit-CAE is a sample that is based on the Kit SDK that is geared towards processing scientific data sets. And we're talking of simulation results. We're talking of inference results. So that is what kit-CAE is. Now, with that in mind, now I'm going to share my screen. And now we're going to start looking into the code. I'm sorry about that. But I was told that's what I should do.
Yes.
So blame Neil for that. So if we can have the Git repo link on the thing here. So this is all open source, right? You have access to kit-CAE on GitHub. So anyone can just go clone it. Once you clone it, it'll take a little while. It downloads some data files for testing and stuff. They're not too huge, but once all of that is done, there are 2 steps to build. And step A is repo schema. This builds the USD schemas, and we'll dig into that a little bit. But essentially, these are the schema extensions that we've developed that let us describe data in USD. And once that is done, you can build the application by doing this, repo build. So not too crazy. This will download all the dependencies that it needs, and it will quickly build, and then your application is ready to launch. So those of who have worked with Omniverse in the past or USD applications in the past, anytime you're thinking of bringing your data into the Omniverse ecosystem, you're thinking of exporting it to USD, right? You do your streamlines, you do your contours, and then you export the geometry. You export the mesh, you export the lines. Well, if you're doing that, it's not going to be very helpful, or it's not going to be really, the turnaround time is going to be slow when it comes to inferencing and live simulation, right? That is just not a workable solution. So what we want to do with kit-CAE is there another way of looking at this problem, right? Instead of exporting data to USD, can I describe my data in USD and let the application bring the data in that way? And that is what this application is trying to, what we're trying to explore in kit-CAE. So before I talk too much, let me just launch the application and let's give a quick demo, and then we can dig into the weeds. So to launch, I'm going to mistype, so I'm just going to go. So this is the command to launch. It should take a second to launch. It does its thing. And this is the application, right? It's a standard Omniverse kit-based application. So I was debating whether to show the data, the stage that we used for the airplane demo, or something basic. In the end, I decided to go with something simpler, just so that we can focus into the USD and see what's happening there directly. So let's open a standard CGNS data set. Everyone is familiar with CGNS, especially those in the CFD world, so everyone's aware of CGNS. So I'm going to open a standard sample data set that's just available online, called the static mixer, right? As soon as I import it, nothing happens, but this thing shows up in the stage. This is, for those who are familiar with CGNS, this is literally how the data is laid out in the CGNS file, right? It's a hierarchical structure which tells you about different element blocks and different field arrays. What we are doing here is the import process is just reading the metadata from the CGNS file and building the stage. This only reads metadata. That's a keyword, right? So this is a tiny data set, it's a few megabytes, but we can easily load gigabytes of data instantaneously, because all we are reading is the metadata to build the stage. So no more converting data to anything. All you do is scan the metadata and set up the stage. And once I have the stage, we'll go into the details of the schema in a second here, but the schema kind of tells me all the information I need to know about this element block, like the B1, P3 element block. Its connectivity stored in this field. It's of type this. This is the elementary, and so on and so forth. All the stuff that we've gleaned from the metadata. Now let's do some visualization operations on it. And all of these are shown under this menu called CAE algorithms. One of the basic ones is just bounding box, right? A quick bounding box. That is my bounding box state set.
Can we just ask, there was a question popped up maybe as you're doing this. One was, is there a preferred format like VTK, CGNS?
Right. So there is none. You can add support for any format that you want. In the example, we have included several. We have included several VTK formats, so VTUs, .vtks, .vtus, VTSs, VTIs. We have included EnSights for surfaces. We have included CGNS for volumes and surfaces. And there are a few others that I'm forgetting off the top of my head. But essentially, you can bring any format that you want and follow the model that we have demonstrated in the sample.
Yeah. Okay.
Right, because it's just teaching. You're just teaching how, like, where to find the data, so you're not converting it, right, Ukarsh?
Right.
Yeah.
So once we have, this is a bounding box, nothing too crazy. Just next step from that, do external faces, right? Just apply the external faces algorithm, and here's our external faces. The nice thing kit-CAE also shows is that how to bring in external libraries to do your work. So in this case, we're not computing the external faces ourselves, we're using VTK to do that. If you have your own custom library that knows how to work with your data, you can bring that into this framework to get the work done. So if I want to color, apply color, standard things here, nothing too crazy. I can select which field I want to color by. Let's say temperature. And it'll color by that.
I'm going to ask you another question, because this is the whole point of this is for people to ask questions. So I apologize to interrupt, but
please.
So this was a question. See that kit-CAE has 3 different themes: plain, VTK, and streaming. When should a user prefer one over the other?
So they are not mutually exclusive to one another. And you'll see once you start looking at the USD schemas, the abstractions that we've built, how to get the data and how to access data, make this irrelevant of where the data is coming from. It could be live, coming from Surveyor, it could be on the disk, or it could be on the cloud, or whatever. It does not matter, right? The application simply just works with just this collection of arbitrary arrays that it has been given from somewhere else. And I think that's where the USD model of looking at data shines, which is very exciting in my mind.
Mm-hmm.
Does that answer the question, Neil?
Well, maybe actually just to take a step back, what is USD? How would you explain USD, OpenUSD, the community? Just 30-second description.
Oh my goodness. Okay. Does anyone else want to take a stab at that? So USD is it's a way of describing a 3D scene, right? It came from the graphics world, or it came from Pixar, if I'm not mistaken. I'm going to misquote things here, so please don't hold me for
No, I
that.
think that's right.
But
Yeah.
right? Yeah, okay. So
Yeah.
it was essentially made for developing these large rendering scenes where you have different actors, different animations, and different scenes set up, right? So there's the notion of a stage. It's your stage. And so the nice thing with USD is, besides the whole rendering stuff, is it also gives you a nice way of describing state, right? It's describing state and defining connections between states. And that is why applications like Kit have adopted that as the way of talking about the stage, right? The standardized way. And there are several applications that support USD as well, right? You can export to USD. There are blenders, and there are many others which can let you build stages using USD or scenes using USD. So if all of this entire ecosystem starts talking in USD, then they can work with each other and they can interrupt. So that is my weak summary of USD.
Would you agree,
Yeah, and I'll
Abby?
also, yes, but I'll also add that it's very good for multiple teams to work together in one location, because there's this idea of layers. Like somebody that's interested in thermal could be working in thermal simulations, and somebody else in flow, and somebody else in something else, and just all combining in one like central location. So I feel like that's that kind of, I didn't realize that when I first started working with them, and then when I did realize, like, it's really powerful to have a central location and a central like scene that we can all communicate in.
Yeah, it's like VRML on steroids, right? Like it's like you had your standard graph scene descriptions that were used like decades ago, and suddenly now, and this is literally on steroids, right? Because it's insanely powerful. Like when I came to USD, I always thought, oh, it's just VRML, it's another exporting format, but it's not. All the composability that Abigail was talking about is what really gives it the leg up and differentiates it from all these other technologies.
Yeah.
So beeswax on faces, let's do something real quick, interesting, and then we'll dive into the stage. Like streamlines, another fun thing to do. All people always want to do that. Let's do a nice little unit sphere. I'm going to transform this to make it a little small. If I can type. And let's go back to our P3 block again. And sorry about the menu changes real quick. I'm going to select seamlines. And we specify which field to color by. I'm going to start using shortcuts now for the sake of time. It's temperature, what are the seed points? Sphere. And what's my velocity? X, Y, and Z. And there are my streamlines. And again, all of this is happening within the application. Like in this case, you're seeing streamlines that are generated using VTK. So it's, the data goes to VTK, we process it, and it's coming back. But there are within, like I said, kit-CAE sample, right? So there are examples of doing different things in different ways. So we have examples of how to do it using Warp, which is another NVIDIA technology, which allows you to write Python code that gets compiled that can then run on GPUs or parallel CPUs, just transparently, and you can write kernels using that. And we have examples in kit-CAE that talk about that. Any questions before we look at the stage? Abby, Neil, do you think?
Yeah, I think it'd be good to get into the even more deep.
Cool. So let me point to where things are in the code, right? So if you look at, once you check out the repo, all of the code that we talk about is under source. In extensions, we have all these different extensions. So there are extensions for adding support for importing VTK files, importing EnSight files, importing CGNS files. And there are these other extensions for adding support for different things, right? So in this case, it adds support for VTK. So if you open a .vtk file, this is where the code is to teach the application of how to understand VTK data model. Same with CGNS sits. So all the code sits here. If you are looking, let's look at the stage first. So if I had saved the stage that we just created out in an ASCII format, this is what it looked like, right? So you have a collection of nested prims, and in here you see it's directly referring to the CGNS file. There's no exported data. It's just lightweight stuff here, nothing heavy. I'm directly referencing the CGNS file on disk. And let's go down to our.
Sorry to interrupt, but this, I guess we probably should have mentioned this before, but this is probably a good one. So you're talking about like VTK, you're talking about CGNS. They're saying, is there a PhysicsNeMo extension in Omniverse Kit? How do I integrate the library into Kit? I guess there's several answers to that, but
yeah. So the RTDT demo source code has the extension to extend kit-CAE extensions to add support for talking to an inference server. Does that explain? Does that answer the question?
Yeah, it's like, I would say it's like hooks, right? So kit-CAE has the hooks to say like, there's the PhysicsNeMo data and grab
Right.
it and pull it in. So
this is actually a good point, because if you look at the scheme, the stage here, so here is the data set B1, B3 that we were working on, right? So in this case, here's this API schema that tells me this is a CGNS data set. So far, so good. But where are the arrays coming from? They point to these prims, which are called these field array prims, right? So in this case, it says it's a CGNS field array. So I know when I'm looking for this field array, I'm going to open a CGNS file and look at the array in this path. And this is what we call a data delegate. And there's an extension that adds a data delegate for CGNS. Now, there's nothing that says this has to come from this file, right? I can easily add another data delegate, which is my inference server data delegate. At which point, when someone asks me for this array, I'm going to talk to the inference server and get that array. So that is the abstraction that kit-CAE offers, which then suddenly makes it seamless to talk to inference backends or live simulations or anything else.
Another question, is there an extension available for the more modern VTU, VTP format? Or are these done
Yes.
through VTK extensions?
So VTU is indeed supported already. A VTP, it hasn't been added just because we didn't have a use case. But if you look at the code, and that's where like it's a sample, right? It doesn't do everything. It shows you how to do a few things so that you can then continue the story the way you want it. So yes, it's fairly straightforward to add support for VTK and VTP. VTU is already supported.
Great.
So going back to the schemas, so where are these schemas defined? If you look at the code, everything is defined under this subdirectory called USD schema, and the schema definitions themselves also look like USD. So here's a schema for, this is defining the base data set. This is defining what a field array is. Here's a definition for NumPy field array. Let's look at the HDF5 one, right? So for HDF5 one, it's an extension of the basic field array, but it also has an attribute called HDF5 path. So it's going to tell me if I want to read, where do I get this field from, right? So I know we're getting close to the time, so I do want to show one more thing. So we're talking mostly CFD here, right? Even with the the blueprints, we're talking CFD, but this thing is applicable beyond CFD, right? So one of our friends, Andrew Hobbs, has this data set where he's running EDM simulations, which are particle-based simulations, and this is like 45 gigs of data, I believe, and it's HDF5 based. Oh, I need to import, file import. There's 45 gigs of data, but like again, same things. It loads the metadata in, it'll create the stage. And now look at this. This is where I want to show the beauty of USD, right? So in this case, this position is coming from this HDF5 array at this path. If I just scroll the time, you see that it changes. It's telling me for this next time step, this is where you're going to fetch the array from. I'm not too sure if it's visible, but for time step 55, it's reading it from 55.h5, and the path is also different. So now I can just glyph this quickly. So if I glyph, pick this particle shape.
Ooh.
And there we go. And this is 45 gigs, almost instantaneous. Doesn't take because we're only, the nice thing with USD is like it can tell me what to read, and then I can only read just that. And that's expressed very nicely within the USD itself.
So there's a question that came up, and I think this is a really good one to answer. Is the target kit-CAE for the end user to integrate into their individual or for companies? And I would say it's more the second one. Most of our focus actually is on ISVs, startups, and some people who are co-developers to integrate it. The point of going into the code here is, whilst you may see when we build a demo, it looks like an end user application. In reality, that is just a sample to show you the art of the possible, where in reality, you're seeing it's essentially a bunch of APIs and samples that show you how a developer could integrate this. But probably most of our time is spent working with, software companies who are trying to integrate this into their platform so that you as an end customer can have this within it. So, that's probably
Yeah, that is exactly right. And that's why, like, when people ask, Divide, doesn't it support VTP? Again, our goal is to it's not a product, right? The goal is to not do everything. It shows you how you could bring in anything, right? We just demonstrated with a few samples so that we cover the spectrum, but then people can take it from there.
So I wanted to ask Abby, like, how people can get started on some of this stuff, but I just thought, can we show that video before? Because you sort of teased that swirling, that's probably not the right way of calling it, swirling thing. I don't know what the official.
Yeah, that's a cool video.
Yeah, so it's a really small step from where we already were in kit-CAE. Now all you need to do is set up the camera, set up the lights, set up the rest of the stage, and voila. So this is, again, Andrew's handiwork there. So thanks to him.
Very nice. So Abby, when you started and now, what's your advice for people who have seen this shown on the screen now, but want to learn how to do it themselves, whether they're in a software company, they're a developer, what sort of links and places would you suggest?
Yeah, I've put together a collection, if we can just go ahead and show that, for some additional resources. But I think a good point is that, we're asking about, like, how do how does kit-CAE work with PhysicsNeMo and stuff like that. And that's really why we built these blueprints, so that you can go and you can download these full blueprints that are an example of how to work with them. So can we show that slide, Zach, of the links of next steps, where we can go? Oh yeah, I think it's there. So yeah, the next step. So like you're saying, Neil, kit-CAE is available on GitHub. Anyone can download it. PhysicsNeMo is available on GitHub. We do have some sample architectures that were built on kit-CAE, so it just shows how to work with kit-CAE or PhysicsNeMo or other APIs and extensions, really custom built for what you're wanting to do. We have a list of blueprints that use these, but we also have some self-paced learning that's really great, that walks you through step by step. You go from PhysicsNeMo and AeroNim to in kit-CAE to visualizing. So that self-paced learning is really great. And also we have this blog that explains it in a little more detail.
Cool. Well, I want to thank you. Gosh, Abby, I know we could have gone on for hours, to get into this. Maybe we'll come back and do another one. It'd be good if people can leave comments or feedback on what they want to see. But I guess this was hopefully to peel back the curtain a little bit, see the sort of way that kit-CAE works. As Abby said, if you go to these links, you'll be able to do some self-paced learning yourself, and hope you can build your own application. And probably the easiest one, if you want to do it, is to go to that buildnvidia.com, the blueprint. That is probably the quickest in that it's already built everything together. But you can go one step further if you want to really customize it and bring in your own stuff by going, obviously, to the kit-CAE itself. So yeah, thank you, Abby, really appreciate it. And thank you everybody for listening in. We'll have another episode in a couple of weeks. For those in the US, hope you have a nice Thanksgiving week. And for everyone else in the world, just have a nice week. So thanks, everybody.
Thank you.
Thank you.